Hey folks, this is me, Vishwas Narayan. I'm the host of this podcast. This is a humble attempt from my side to do a lot of .NET. I'm just calling a lot of .NET developers in the series, and we're just having a lot more fun. And I think Sandeep Bhai is always there for us. He's in AZDale, India, and also trust me, one of the best guys that you can really look back forward to because a lot of times, I always feel like, okay, अरे क्या हो सकता है जिंदगी में, like 10 years of experience, 15 years of experience, you get chiseled as an engineer, and over a course of time, you just build yourself as a better engineer for the tomorrow's world, right? So this is what it is all about. So thank you, Sandeep Bhai, for teaching me how to be on this track of development and things like that. Of course, we have a lot of talks out of this podcast and things like that. We actually talked a lot. Don't worry about that. Oh my god, next level. But at the end of the day, we have learned a lot. We have just make sure that we all have that path of learning in our life. So thank you so much, Sandeep Bhai, for giving this podcast. Means a lot.
Thanks, Vishwas. Thanks for having me here. Hopefully, I will enjoy this podcast and we'll have a great time together during this podcast.
Yeah. So let's just start with this introduction. Like, what is this .NET framework all about? Like, it's an ecosystem today, right? But how did it evolve? Because I wanted your perspective about all these things that you're seeing, because you're seeing .NET from a very long time. So what is .NET ecosystem today when you compare it to the earlier days that you started working?
Yeah, sure. So when I started, from the start of my career, I remember I started in 2006 working on .NET Framework as my first job. So that time I started with the version 1.1. And 2.0 was also in market, but some of the companies were not migrated to that version. So 1.1 was the version that I started to work on, and I started to work on with Windows framework application, like Windows Forms application, basically. So that was my first application where I worked on .NET. And then time by time, as the .NET evolved, like from version 1.1, I got to know work on 2.0. Then 3.5 was introduced, so on the versions were introduced. So accordingly, I got to work on different templates of the .NET application. So after 1.1, I got to, when I got introduced to the 2.0, the 2.0 basically, the version of .NET. So that time I got to work on web applications also. So from Windows, I evolved to the web applications journey, projects, we can say. So then once I got into the web applications only I explored. But along with that, what I found, like .NET introduced several templates for development purpose, like not only Windows Forms web applications, but along with that, they introduced some mobile templates for mobile developers. So this journey evolved. Like, so as we see, like example from 1.1, .NET evolved from 1.1 to 2.0, then 3, there was in between 3.0 also. But then 3.5, 4.5, I mean 4.0 was also there, then 4.5, and so on. Like it went ahead, like 4.6, 7, 8. So what happens, like whenever a .NET introduces a new version, so that time they add some extra features to it. So on high level, like if you see what features they added, so they added several features, like as I said about the templates. So templates that they would, like basically the project support, what frameworks or projects they will support, that they have introduced, or the testing frameworks, the testability support, unit testing frameworks, unit test supports. These things they evolve, means they have introduced into the .NET framework as they evolved with different versions. And for me, like according to the .NET framework evolution, or the hierarchy that they have introduced, I think the .NET Core was a main milestone I will see from the .NET perspective that Microsoft has introduced, because .NET Core is something where they have introduced open source initiative from the .NET or Microsoft side, and also they have added a .NET Core support for various platforms, like not because previously .NET was specifically for Windows. Like if you're going to run some applications on .NET, those will be portable to Windows only. There were several versions like Mono.NET and all, which were trying to give like some support for other applications, like other OS like Linux and all. But the framework which was mostly used by developers worldwide, the .NET was not directly portable to Linux. So with .NET Core, it was possible. With .NET Core, it was possible to write applications for Mac OS, Linux, and Windows. So portability is the main thing. What I find very best feature from the .NET Core, what they introduced, and it again took .NET to a next level, like containerization, microservices. So everything got introduced with the .NET Core. So this is the evolution at high level, I will say, what I saw during my career and during whatever experience I got into .NET.
Yeah, that evolved, but companies had this one task, like every .NET has its own migration. Of course, it's still C sharp, but the way in which frameworks were also built was also changing, right? Everybody had their own open source support. Of course, it still has LTS versions every alternative years, but yet there was a reason for every company to migrate. So how did companies strategize in migrating from one version to other? Because when you told you started, of course, version 2 was already there, but companies were still having 1.1. So I know for sure that there was a reason for them to adapt to a new framework over a course of time. So how did companies strategize for that? Like in the earlier days and now, how is the strategy different? Because like migrating from 3 to 5.1, that's not a big deal, but today migrating from 3 to 6 probably is going to be a huge pain. So what is it all about when we are talking about all these applications today?
Yeah, so which was your questions were right. Like the transition, if we take say example, if you take example of a .NET framework to .NET Core, that's a big transition because everything is new. If we see concept-wise, what .NET Core has introduced, like middlewares, or they have introduced some service lifetimes. Like you can add a dependency injection is a pattern, it is a design pattern. If you want to add that in .NET framework previously, you have to introduce, you have to use some NUnit containers, IOC containers basically, to introduce that pattern or to use that pattern. I'm just giving an example, high level. But if in case you go to .NET Core, so that is inbuilt. So it's something where you don't want that plugin at all now, right? So that is not needed, but configuration is also different. Like what they have introduced, the configuration files is something different. Like they have in previous .NET framework, we used to have only web.config, and there was a main class program.cs was there. But now with .NET Core, we have startup.cs, in which we have different services. Like we have different methods, basically configure services, configure. So where we create our own pipeline of .NET execution, like how .NET will basically execute the flow. Like suppose there is a web API, or there is some, we can say, let's take example of MVC project, model view controller template, where if you are hitting that particular action method of that view or that controller, basically you're calling that from that view, a particular action method. So what will happen? Your request will execute in particular manner in a pipeline of execution. So basically there is a request processing pipeline of .NET, which was earlier different in .NET framework. .NET Core has some different, which where you can go and you can write your own middlewares, your custom request pipeline. Like you can customize your exception handling, your routing, basically how you define the routes, or you can. So the routing was also there in previous framework, but now they have given you own control by giving you middleware access. So this is a big transition if you see. So for this, as this is a big transition in terms of architecture, in terms of layout and structuring of code. So obviously, when we go for such migrations or such transitions, so there are several architectural patterns that come into picture, or there are several design patterns that come into pictures. How to migrate the code, how to migrate the code repository. So if I say if I have a service oriented architecture, and I have got, say example, say hundreds of services with me, which are into traditional .NET. Say example, WCF template is there. Okay, so that WCF template will have hundreds of services, and now I want to migrate it to .NET Core application or .NET Core microservices, or we can say web APIs, we can say. So it's something like we are keeping a service tier as it is, but we are migrating into advanced level. So basically, web API has its advantages over WCF. So if we're taking that example of migration, just a case, use case, we can say. So in that case, what happens? You can't do everything at a scratch. Like you can't say like I have 100 services, I will do everything at 100 at once, and I'll migrate everything. So that time some strategy or some patterns that come into, like we have some say incremental approach, where you will take say maybe a 10 services and you will migrate them, and you will add it into your production layer. And obviously you will have some backup into the old services as well. Like something goes down, something goes wrong, then you can ultimately make sure that your old code, like old functionality comes up, that will take care of your existing, we can say, production system. So these things happens in background when we go for such huge migrations of frameworks. So this is overall architecture decision, like how to go, and also a delivery decision, like how to migrate step by step.
.NET is a culture, by the way. It's not even a language also. It's not even perceived as a framework. It's like a culture. Like if you have a .NET dev in your team, that means you have a great way of understanding, okay, this is what application is. Because I think it brought portability. That's true. Because I think Flutter came in. Flutter had portability since 2017, but I think .NET pioneered the ways. I think Xamarin came in. Xamarin was huge in that. Like Xamarin really changed the market for the native applications which were built. So now we come to a problem where there are hundreds of frameworks to choose from. Like, .NET, when you just install, there are hundreds of frameworks which are already added into it. There are ways in which you can really deliver some stuff very easily. Like you probably today, you need not have to code too much in order to be a .NET dev. You should know where to get the code from and also where to take the code from also, right? So it's always there. So we are now playing with a .NET culture and the frameworks which are coming for the marketplaces. Of course, all of them are perceived to be as open sourced ones, and also some are third party ones which are paid. So what is it all about when we are talking about this kind of a culture which is already there in an organization, plus those evolving frameworks like Mavi is there is Blazor, there is this, that, oh my God, there's hundreds of components which are already there. So what is it all about when we are perceiving such kind of a tech today? Because nobody actually thinks of .NET development in their college times. Some people just touch it, but nobody thinks of it in a core fashion. So how are we perceiving it today? So .NET culture.
Yeah, so usage wise, or say how to use, like which template to use when, and when to adapt to which template, or like say example Blazor, MVC, or APIs. So which template to use? That's what you're asking, right? Like when to shift to which type of frameworks, or which type of we can say type of applications, right? So like
and also we are also trying to build a lot of native applications, right? So how are we just trying to build such kind of an application? So that's my question.
Yeah, sure. So native kind of like if you say cloud native, or basically native applications. So .NET, like recent .NET change, recent .NET developments, or recent .NET frameworks, I have huge support for say native, or say cloud native kind of development, because the libraries that they give given are something which supports cloud native development, or say native development. So if you take an example, say React or Angular, so it's something as a separate framework. But with the .NET and Visual Studio, like if you say .NET, obviously a person will go for Visual Studio. That's what my thinking is. Obviously, there are, like, you can go with Notepad also, but Visual Studio. So Visual Studio is a ecosystem of a .NET framework. So as the .NET framework has evolved, Visual Studio has also evolved. So with this current advancements of .NET framework and the advancement of Visual Studio, so we have so many things integrated into the templates. Like if you want to go and work on say front end app, and along with that you want to do, we can say example, you want to do some full stack app development. So you have several templates built into the Visual Studio, by which you can just go and fork a boilerplate over there. Boilerplate is given over there, and you can just start developing the applications. So it's very easy for a beginner also, or a professional also, like who wants initial boilerplate available to start the application or start the coding, or to explore new coding. Like suppose if I'm new to the React application, React technology basically, and I want to explore that. So it's something like if I'm doing everything on scratch, so I have to go and I install npx or npm, and then I have to do the package management and everything, and do my basic installation. Or obviously I can fork some boilerplate also, but it's something like you have to go and do it from scratch. But that's with something with Visual Studio, you can easily do it. So this is I will say the culture that is introduced along with .NET framework by Visual Studio also. So Visual Studio gives a very easy to develop and a productive way or efficient way to develop .NET Framework applications. .NET Framework applications.
That's true. But today we are talking about something like, okay, full stack development is everything. Like everybody can't do full stack. And you also should be knowing the fact that nobody can know it all. Like something like, of course, you know an abstraction layer which is a little lower, you know a little abstraction layer which is higher, but you can't be a know-it-all person because full stack is so huge. Like something like, I think 1992 CERN website came in and CERN really changed the way in which we are thinking about, okay, there was a website called as Amazon. Of course, we have forgotten the shade of the gray, which is already there. But now when we think of something like a sort of an application which is already built, something like, okay, there's a production system which has millions and millions of lines of code. There is full stack already, which is there. So what is it all about when we are learning full stack and when we are getting into the industry, which is full stack development? Because nobody has an idea about, like, even I too don't have an idea, complete idea, because I've never seen an industry with such a full stack manner, because I never worked on a complete component end to end. So I just wanted to know, how is it all about when a fresher like me wants to enter an industry with an aim of becoming a full stack developer at the end of the day?
Very right. So full stack is one career path, I will say, to enter into industry. And full stack is somewhere like you do everything from start to end. So if you go for a full stack interview or full stack professional interview or full stack, if you want to pursue into full stack career, so it's something where you will be asked from front end frameworks like say Angular, React, to the CI/CD pipelines like deployment or DevOps part. Everything you will be well say drilled down by the interviewer. So you have to know everything, but it's not necessary that you have to be at advanced level for each thing. Like even if I take say when I take an interview, so I don't go and drill down a person into that advanced level or deep level of each thing. So I just wanted to know, like example, React is there, so what concepts he knows, what things or basic features of React he knows, by which he can just start working on that. Because see, advanced features is something which you can explore on the job also, because everything is getting advanced. Like if you take an example of React framework, it is getting advanced, like we can say a week or 2 weeks ahead, you get something new features introduced. So it's not something that everyone will know everything, but basics should be clear. So that's what I think a full stack professional should have from every tier, like not only from like start to end, from everything, like from front end, middleware, like APIs, from the back end database, and to little bit of I will say develop deployment. Because when I interview people, or when I try to talk to people with full stack, when they say that I'm a full stack professional, so most of the time they don't know how or where their applications are getting deployed, how they're getting deployed or where they're getting deployed. They don't know like what is containerization, what is Kubernetes, what is Docker. They just know conceptually, but if you try to ask them like scenario, like how you will deploy it into container, or how it will be pushed, how the images will be created, so they don't know that. So at least initial knowledge or basic knowledge of these things, everything is needed. And a full stack developer is a profession where you don't need to have too much advanced knowledge, but it should be the thing like if you are given an assignment or if you're given a problem statement, you should be able to do it by learning or by researching it. So that's what my understanding on full stack profession. Yeah, and coming to the next point, that what you ask, like if someone wants to get into the full stack profession, so full stack profession is one, I will say, a career choice or career path. But along with that, you have several paths. Like you have front end development path, you have back end development path. So if someone wants to get into the thing and they think that the tire is so much vast, like full stack is so much vast to cover everything or to understand or learn everything, so you can start with, like if you have interest on UI part like HTML, CSS, you like working on that or you like playing with that, you can get into front end. And partially, like if once you explore, like say example React, Angular, these frameworks you explore, so obviously that comes with the Node.js part, so you have npm and all. And ultimately you can switch to microservices or services, you can explore some APIs, so then it builds you a portfolio of a backend developer also. And then you can explore database, so this way you can progress. So it's not necessary you have to know everything, but at least you can start with at least backend side or front end side. and then slowly move to each of this tier and understand the full cycle. So that's what I will say about how to enter into full stack or back and front end things.
That's true, because like let's imagine, okay, somebody who is
Yeah.
doing Azure functions, it has all the
Mm.
components, and
Yep.
documentation is pretty huge. Like, it's actually
Mm.
an year's syllabus. I can say that because
Yeah.
Azure DevOps is and Azure DevOps is huge. It's not like,
Mm.
okay, we just have tools here and there. Of course, it's still YAML at the end of the day, but the way you are writing the code is very different. So I just wanted to realize, like, we have something called as a database today, because
Yeah.
we have something called as a database, and now we are talking about scalability aspect of it. And of course, you talked a lot about the .NET framework, which is always very particular about the native application, which is all for the iOS, Android, Windows, and everything. Web, basically, web is also what we also consider here. So it's a
Yes. Yes.
fully fledged deployment on all the platforms. Plus, it has ability to just give a support for all the different aspects that we are talking today. Something like, okay, there is a .NET thing, there is this and that. What next? So there is always that what next. So we are now thinking about the scalability and the monitorable aspects with the reliable resilience and all these things added. So how are we now trying to perceive cloud when we are trying to architect some things? Because you saw the .NET world, which was like VMs. Something like procurement of VM was 3 days. Just make the folders, just add the code there, like what not. Everything was always the chaos there. So what is it all about when we are talking about databases and scalabilities and things like that from your perspective? Because .NET devs, I think they have a huge perspective for all these tech that we are talking today.
Obviously. So when you say like you're a .NET professional and you go into industry, you try to give some interviews or you want to get hired, or even if you're working at current organization, so they will not only give you a .NET work, like you want to work, you have to work only on say Windows Forms, web applications, and you have to work with C# language. That's not the thing. They will ask you to work on database side also. And you have to understand like how to connect to these databases, how to work on different objects of databases, like example, store procedure, triggers, views, functions. So there are so many things. I'm talking about relational database, which I saw in earlier stage of my career. But along with that, now with RDBMS, they have introduced something NoSQLs, where the scalability with clouds, we can say what you talk, it comes into picture. Because with NoSQL databases, it's like they're huge. And they're growing like petabytes, and say more than petabytes, we can say, the daily basis, or the basically the uploads and the increments of the data into the NoSQL is very huge. So that is one aspect which comes into with scalability and cloud databases. But now relational databases also moved into cloud. And in terms of scalability or with the cloud availability, I will say it's very good feature, because from the cost perspective or from a usage perspective, it's possible. Or even from, like as you said, we initially we had virtual machines, or say a virtualization era, where you have to do everything standalone, like you have to work or depend on the network guys to scale your systems, or to have your infrastructure scalable, or to plan your infrastructure. But now a developer can also do the same things with cloud availability, cloud functions. So it's a huge evolvement, or we can say evolution with the cloud, which has been brought into the database. And from these two things, like relational and say NoSQL kind of databases, it is again a choice. Like whenever we select those databases for usage, so it's not the case. Like if even if I have some friends who are totally into database, or they are data architects. So when I talk to them, I try to understand, like what about databases. Like we had previously, they also had worked on relational databases like PL SQL, Oracle, and SQL Server. What about NoSQL? Like what it will do? Like will it totally replace NoSQL data, I mean relational databases? What will happen future? But it's not the case. Your relational database will stay as it is, because whenever you have transition kind of things, or basically a data which is we can say a transition oriented, or which is having a complex relationship in between them, obviously a database with this kind of things like SQL or Oracle will come into picture, and they will continue to have this support, continuous support. But if you going for say document based, or we can say key value based databases or graph based databases, then NoSQL is something is will be your choice. And there we have to use some the advanced features of like scalability or cloud oriented features, which will be must, we can say, for their implementation, looking at the huge size of the data and the basically the expectation of availability that is needed.
That's true. That's true. Because like we have a requirement of that efficiency that is always there. It's something like, okay, you have hundreds of developers who are developing code, you have hundreds of people who are also just contributing for selling that kind of an application. And yet it's always that cloud resilience that brings up that 100% availability for every one of us. So now when you are talking about databases, it's huge, like something like, okay, Cosmos DB is there, DynamoDB is there, there's that, there is always a comparison which always happens, like something like, is this DB good? Is that DB good? Something like, okay, all the DB is good, let's just use it all. It's impossible because every company has their own compliances, everything. So how important is it to understand databases? Because I'm an ML guy, like I love to work too much on the data set that is being collected. I love to actually work behind the architecture which is already being involved in such kind of application. So how important is a database concept for every person? Because when you think of doing certifications, I think probably that's one of the most key component that is being tested out indirectly or directly. That's how they do it, because that's what database, that's what the flexibility of the cloud is all about. You need not have to put the NVMe drives again and again. It just gets scaled out to the requirement. So database schema is there, in DevOps. If you just go on and look at what is the database schema going to be, it's going to be very different. So what is it all about when we are talking completely on the database as a concept? So how is it all about when we perceive such kind of a tech for the tomorrow's world? And learning it is something which is a next level of complexity that we are adding it. So what is database to the world?
Yeah, so database is everywhere. Even if you're a full stack developer, you're a backend developer, you're a front end developer, anywhere you are interacting with data only. So even if you're a front end example, let's take case by case, like for full stack, if you're a front end developer, you're accessing some web APIs. So your web API is doing what? It's nothing but interacting to database. When you're posting something, you're fetching something, it's nothing a database. It can be any sort of data. It can be your documents, it can be your relational data that's we discussed previously, like transition oriented data, like bank accounts data, or it can be let's say example, if Facebook that you work on, like those things, the likes and comments and shares and posts and everything. So it can be that kind of data. So scattered data, we can say, or non-structured data. So it can be structured, non-structured data, both ways. And so everyone has their interaction with database as a developer. So it's very essential, very important, I will say, or essential, I will say, to understand the database concepts. Because when you know these concepts as a full stack developer or a backend developer, front-end developer at least will not get that much, I will say, understanding, or it's not needed that much. But for backend developer, it's a must, because you have to understand the schema, you have to understand the relationships, and in case some issues or some design you have to make. So that time you have to think about database schema also, how your database schema will be, how your structure of your database will be, and then accordingly you have to design your front end, or we can say the data, I mean the backends. So database, so example, if we take about example of any ORM system, object relation mapping system, where you interact with the database. So that time they have several approaches, like they either so you design a schema basically first. You either design it on database side directly, or you design it in a code by doing some classes or models, this kind of things. So it's always a data first, I will say. And nowadays the trend that is going on, as you said about ML and AI, everything. But if you see, if you go and see the details, or if you take example of any certification also, let's take, you are taking example of say AI certification, the foundation level certificate of Azure. You'll go and find like there are some database concepts involved into that also, which you have to understand, or which you have to know, because AI and ML will evolve only on data. It's something training data and everything, training data sets and training feeds that you're giving to your AI and ML, and it's learning on that. So data is something a base of AI and ML also. Database is very crucial to learn, I will say. And everyone must learn these things. Either you learn structured database, like relational databases, or you try to exploring the NoSQL databases. So it's important.
Yeah, that's true. Because like when we have a lot of things to be learned, it's too complex. But at the end of the day, when you are in that environment, you know what is required, what is not required, and you just kickstart your career and you just say that, okay, this is what I need to learn. So now let's just talk about the certifications, because it's not the number of certifications, it's also the quality in which you're doing it. Like something like you have 15, 30, 40, 50 different certifications, but you don't really have understood what's the depth and concept of all that technology that you had actually gone through. And of course, there are people who have really done amazing. Like there are truly amazing people who have done good number of certification, good number of uh, webinars, and also a lot of articles also. So what is it all about when we are getting in to the world of certifications? Because like something like, it's a different requirement. It's something like that kind of exam is not written in your curriculum. It's always a different thing. So what is it all about when we are talking about cloud certification today?
Yeah, so certifications, I will say, first of all, is not needed. If you ask me, or if you go and research on your own about certifications, if you want to go and give an interview somewhere, or you want to get selected somewhere, they will not judge you on your certifications. If you say like, if I have 12x, people say in the LinkedIn or somewhere, like they have 12x and all the certification of Azure and AWS and everywhere, but it's not needed to succeed into interview or to enter into any cloud profession as such, because a certification will give an edge, will give you an edge over other candidates to get into that place, I will say, or maybe to get just calls from the recruiters, but it will not help you into cracking interviews. It will only help you into cracking interviews if you go by the syllabus of certifications, if you understand each and every terminology, if you know how those concepts are implemented, how those concepts are working, if you have done some POCs on that. So let's say example, if I'm a beginner in DevOps and I want to enter the world of DevOps, so certification will be helpful for me. How it will be helpful for me, I'll give an example. Like say example, if you take an example of Kubernetes. So Kubernetes is an ecosystem which will help you if you learn the Kubernetes, if you do a certification of say CK. Okay. So if we talk about certifications, so certifications, I'll not say that certification is important to get into industry or to get into a profession. If you ask me, or if you also Google on your own, or you research, or if you ask any experts in the industry, they will say that certification is just a benchmark, or just we can say, like if you like say, I see some of my colleagues, they are not a computer science graduate also, they have done some BCom graduation and they're still into IT. So it's something like the same. You don't have to be certified to get into the industry, but certification gives you an edge. Certification gives you a syllabus, like what to study or what to understand or what to practice, which POCs or which concepts to implement, which concepts to understand. So it gives you that, I will say, the template or the syllabus. So it's something which is important. Like even if you don't go for certification, or if you don't want to invest on certification, it's fine. But you can at least get the track. You can understand the concept, the flow, how the things are like. Basically, example, if we take an example of CK, I will give an example of Kubernetes. So what I know two tracks. They have introduced third track also, but I will take an example of two tracks. Like CK is there and CK AD is there. Like Kubernetes, a certified Kubernetes administrator and certified Kubernetes application developer. So what these two tracks are, if you want to do some development along with Kubernetes, so you can go for that track. And if you want to go into DevOps, or where say administration things comes into picture, so you can go for CK. So how I will go for it, like if I'm interested into Kubernetes, if I'm say if I'm working on Kubernetes also, and I want to give myself as a certified, or say a benchmark, like yeah, so I am something who has some certified knowledge on this particular technology. So I will go and explore the certifications. I'll go and understand like which track best suits to me. Example, if I'm a developer, I may go for a CCAD application developer template. or if I'm an administrator, or if I want to grow into DevOps kind of things or administration kind of things, I will choose a CK, like Certified Kubernetes Administrator. So this way, I will choose, or I will tell someone to choose which certification they want to pursue. And after choosing the certification, it's my responsibility, or it's that person's responsibility, to understand the flow of the contents, whatever they're specified into the certification track, practice those, implement those. And if you get the certification, it's very good, like it's not bad. But sometimes what happens, like I've seen the trends, like people go and just read the dumps and they give an exams, so which is not beneficial for them, like just to get the notation on your resume, like you're certified. It's not enough. You have to practice, you have to learn, you have to put the efforts, and then it will help. It will obviously help, because you know the concepts to be implemented, you have the knowledge of that technology. So this is
Yeah,
something I will say about certifications.
that's true. That's true. And also, like, how did it help you in the DevOps journey also? Because, like, it's not like everybody has that DevOps wala touch in their career. Like, like
Right.
if you think of me, like exactly in my engineering days, I was like, I left the DevOps 4 times. It was like it was never coming to my hand, and everything was out of the reach to me. That's what I felt initially when I read about that technology, and I was just wandering around what will be this technology all about. So now, when you think of a tech like that, so how are we actually making sure that we also learn DevOps with this? Because all certifications now have that one touch of DevOps every single time. So how did this help you in understanding what is DevOps?
Yeah, so as far as my understanding is concerned, I think DevOps is not only about a tool. Like if you go into market and find or learn or want to learn about a particular tool of a developer, you'll find like say hundreds, or maybe I'm wrong, thousands of tools for a DevOps. Every day there is some new tool that is introduced for a DevOps. So it's not about tools. DevOps is a philosophy, I will say, a standard definition of what public say, but what I understand, it's a philosophy, it's a culture. So it's not something where you will say like, yeah, this is something I will put into a DevOps. So it's everyone's, I will say, like every company or every organization or every institute has their way of implementing DevOps. How they will nurture that culture, how they will implement that culture, it's at their own place. They will decide that how to implement. But if we want to say as a beginner or as a new person, or if I want to, like say example, if I'm new to DevOps and I want to enter into DevOps, so obviously I will go and choose some tool which may be buzzing in the market, which will have more jobs, or which where will I get to practice more. Basically, why we look for jobs, because means what why we look for such tools where we'll get exposure and we'll get some jobs and we'll get some hands-on. So how to enter this space is like I will go and explore this tool, and I will have some like portfolio of my own, maybe on GitHub repo or somewhere. I'll create POCs, I'll showcase my work. Even if I'm not having experience, I can go and showcase my work. Like if I'm giving, if example, if going for a, say I'm a full stack developer and don't have like total experience with DevOps, and I want to enter into that space. I'm interested into entering into that space. And if I'm going for an interview and I'm saying like, yeah, this is my background, this is my experience. So yeah, obviously, theoretically, I will answer. I will give answer if I'm prepared for the DevOps concepts and everything. But when it comes to real life experience or real life understanding of the technology or that flow, I will have to showcase something. Like example, I can talk something about .NET because I have done that work practically. But if I don't know about DevOps, then I will have to choose some tool. I have to showcase my work, POCs or something, and that will help me land into DevOps things.
Yeah, that's true. That's true.
Yeah.
Yeah. Thank you so much, bro. Thank you so much for such great insights. I think we just covered a lot of things. We just covered a lot about, of course, .NET was the main stuff, but at the end of the day, we also covered a lot of other things out there. Of course, when you think of AWS, Firebase, GCP, Azure, like they are, they all have the .NET ecosystem, which is already there in their culture. So we can't complain about it that .NET is not going to fetch me a lot of interaction like Python or something, because it's adapted in some market, but .NET is rocking the world to some extent, I think. Thank you so much, Sandeep, bro, for all this kind of great insights. And thank you for giving such great insights on my podcast on the .NET series. Thank you.
Thank you, Vishwas. Thank you for giving me this opportunity to talk here.